So today we are going to be looking at transformation of alcohol to what we call the carbolyls. Now, when we're talking about transformation of alcohol to carbolyls, the carbolyl here we are referring to what we call the aldehyde, or we have what we call the alkanone. Okay, they are the carbolyl that we have there, which are also called the alkana. Okay, now with respect to that, we are going to start without wasting much of our time. So the first one that we have here, which is number 1A, is what we call oxidation of what we call primary alcohol. So when it comes to oxidation of primary alcohol, it has to do with conversion of a given primary alcohol into what we call aldehyde. In this case, we use what we call suitable oxidative agent to get the exact needed product. Now, there are some oxidative agents, they have to produce what we call carboxylic acid in the process, which is not needed. So what we actually need is what is the aldehyde. So with respect to that, we are going to select some what we call oxidative agents which can actually perform the function of converting a given primary alcohol into what we call the aldehyde that is needed, that is the alkana. Now, in this place, what are the examples of suitable agents that are needed there that can perform the needed function? Among the oxidative agents include what we call the PCC. We also have what we call the PDC. Okay, these mentioned oxidative agents that we have there, they are capable of converting what we call the primary alcohol to what we call aldehyde without forming what we call subsequent carboxylic acid in the process. Now, with respect to that, we are going to start from here. Using the case of what we call the butanol, that is 1-butanol as an example. So in the presence of what we call the PCC or PDC as what we call oxidative agent. Now, using what we call H2Cl2 alongside, it produces what we call the CH, which is the butanol. Take note of that. It produces what we call butanol. So the butanol here is the aldehyde that is needed. There is no formation of what we call butanoic acid, which is the subsequent product formed alongside. So that means PCC and PDC are suitable what's it called oxidative agents. Apart from this, we can also use it for what we call formation of ethanol. They can ask a question on this, that you should write equation for preparation of ethanol. So here we go. Using what we call ethanol, in the presence of what we call the PCC as a good oxidative agent, where we have what we call CH2Cl2, it produces what we call the ethanol. Ethanol is formed in the process involved. So this is another form of the equation which you can also write in form of the what of the formula. Now I proceed to number 2 that I have there. Number 2 that I have there now is oxidation of secondary alcohol. Now I want you to know something carefully. What is that? How do you recognize primary alcohol? How do you recognize secondary alcohol? For primary alcohol, you have something like this. For primary alcohol, they usually have one alkyl group, they have 2 hydrogen atoms, then with 1 OH. Take for example now, see we have R, we have H here, we have what we call the OH in this place. Add this alongside CH2, add it alongside to A. Now, this is how the primary alkanol look like. So basically, what we want to replace, since it is oxidation, what we want to replace is what? Is the hydrogen that is present there. Okay, so for secondary alcohol, we are going to have 2 hydroxyl group, then we are going to have CH, we are going to have OH. That is what we have there. So what we want to replace there is what? Is the H that is present there. So where there is no H, which is the tertiary alcohol, then they cannot be converted to what we call aldehyde because we don't have hydrogen to replace in them. Okay, so I proceed to the second one, number 2, which has to do with oxidation of secondary alcohol. Oxidation of secondary alcohol. For the oxidation of secondary alcohol, now what we actually have here is that we need to make use of what's called the chromic acid. Okay, using the chromic acid in the presence of what we call H2SO4, then we are going to get the needed product. In this case, I'll be using the case of what we call the Na2Cr2O7 as what we call the oxidative agent there. Okay, in the presence of H2SO4, and this will go together with a given compound which is called the 4-ethyl cyclohexanol. 4-ethyl cyclohexanol. Now here we go. For the 4-ethyl cyclohexanol, this is what we have there. 4-ethyl cyclohexanol. In case if you want to get the formula for the arrangement, the structure of 4-ethyl cyclohexanol, you have to draw this like this. Then we have what's called the benzene ring there, which is very, very important. You have to label this. It's very, very important. 1, 2, 3, 4. So this is the position of this ethyl there. We have this. Then at this particular position here, we have what we call the OH. This is what we call the 4-ethyl cyclohexanol. Now, this compound that we have in this place, in the presence of what we call N2Cr2O7 using H2SO4, then the product that is going to form there will be 4-ethyl cyclohexanone. Take note of that. 4-ethyl cyclohexanone. So we are going to have this. This is the exact compound that will be produced there. Okay, this is the product we are actually converting in this place. So the 4-ethyl cyclohexanol is the one that we have here, while the one that we have in this place is called the 4-ethyl cyclohexanone. That is the exact compound that is being formed there. So I want you to take note of this carefully. You can come across a question on it. From one of the past questions, they asked something related to this. You were given this, in the presence of this, then you were asked to write the product formed there. It's either you draw the structure of the product or you write the name of the product formed there. So I proceed to the what we call the Jones reagent. Exactly, Jones reagent. That is what we have to discuss about right now. So when we're talking about Jones reagent, why do we have Jones reagent? Different scientists or different chemists, they usually come up with a typical reagent that suits a particular reaction or process. The Jones reagents include what we call addition of solution of chromic acid together with what we call H2SO4 make up what we call Jones reagents. Take note of that. Jones reagents. Jones reagents. Take note of that. That is what the Jones reagents contain. So with the help of the Jones reagent, we can actually have this particular equation there, such as when we have cyclooctanol in the presence of what we call the H2Cr2O4, which is what we call the chromic acid, in the presence of H2SO4, is produced what we call the cyclooctanone. Exactly, cyclooctanone. That is the exact compound needed there. For what we call cyclooctanol, that means you need to draw the structure, octagonal, where we have this. If you check this out, 1, 2, 3, 4, 5, 6, 7, 8. Now that is the what? The octagonal ring there. Then what do you have to do? In any of the position, you place what we call the OH there. This is exactly the structure of what we call the cyclooctanol. So then it is converted to what we call the cyclooctanone. Then we are going to have this there. So to any position, you just add your what? Your CO to it. Please don't forget the functional group. of the alkanone is CO. Is very, very important. Then I proceed. Apart from the oxidation, dehydrogenation can also be accomplished with various catalysts and conditions. Now, when we're talking about catalysts and conditions here, all these ones that I have mentioned, they are simply laboratory preparation, okay, laboratory process or laboratory reactions. Industrially, how do we convert what we call aldehyde into what we call, how do we prepare the aldehyde and the ketones? Industrially, there are various processes that we can use there. So let's talk about industrial preparation of this aldehyde and ketone. Industrial preparation. Under the industrial preparation, okay, from primary and secondary alcohol, okay, using what we call a catalyst. Some given catalysts in this place include what we call the copper metal. So under industrial preparation, if they ask you to mention the catalyst used there, so the catalysts include the following catalysts. The catalysts include the following. We have what's called the copper metal. Copper metal can be used as catalyst there. Number two, we also have what's called the copper chromates. CuCr can also be used as catalyst there. We also have the catalyst of copper oxide. It can also be used as catalyst there. So these are the three industrial catalysts. They are different from the laboratory catalysts that we've mentioned earlier. A sample of the laboratory catalysts include the PCC, the PDC. We also have what's called the Ne2Cr2O7. All these ones that I've mentioned, they are laboratory catalysts. So you can be asked to mention them. So know the one to mention and know the one not to mention under the given question. Now I proceed. Now, what are the industrial preparation that we have there? Under industrial preparation, we have the following there. We have number one, where we have what we call the N-butyl alcohol. N-butyl alcohol can be converted to what we call butyl aldehyde. Butyl aldehyde in the presence of what we call the copper chromates at a particular condition, which is about 300 to 350 degrees Celsius. That is that. N-butyl alcohol can be converted to what's called N-butyl aldehyde in the presence of copper chromate at temperature of about 300 to 345 degrees Celsius. We also have this one there. Let's make this A. Then we are going to have 1B there. Conversion of what's called cyclopentanol into what we call cyclopentanone using CuO as a catalyst there. The condition required is this to about 300 degrees Celsius. 250 to 300 degrees Celsius is the condition required there. And this is this, and this is this over there. So under the industrial preparation. Now let's talk about what we call oxidation of tertiary alcohol. Now for tertiary alcohol, it should be noted that the tertiary alcohol cannot be converted to aldehyde and alkanone. So why? This is the reason. Let's talk about this carefully. So I came across the past question from 2017 of the past question that says describe the oxidation of the tertiary alcohol. Another question from another year says that why is that the tertiary alcohol cannot be converted to aldehyde and alkanone. So this is the reason behind it. The reason behind it is that number one, for the tertiary we have C, we have R, we have R, we have another R here, then we have OH. As you can see in this place, There is no hydrogen available. All we have in this place is alkyl, while the one that we have is OH hydroxyl. So with respect to that, this particular tertiary alcohol does not have any hydrogen that can be replaced. That is the answer to the question. So how do you answer the question in statement form? The tertiary alcohol does not have any hydrogen atom which can be replaced, or which can be what? Oxidized. What is oxidation? Oxidation is the process of removing hydrogen, addition of what? Oxygen. So in this place, there is no any hydrogen we want to replace air, and we don't have anything to do with this because this is the functional group. The reason why we call it what? The alcohol. So the reason why we call it tertiary alcohol is the presence of the what? Of the three alkyl groups that are present there. Okay, so there is no presence of hydrogen which can be replaced. That is the answer to the question. That is what is expected of you. So the question is not that hard, and the answer to be provided is as simple as to say that the hydrogen atom is not available in the tertiary alcohol, and that is why there is no room for what? For oxidation. So next class, we are going to be looking at the module 1 unit 4 of the material, which has to do with CHM 416, which is organic synthesis. Thank you very much.